Hi everyone, welcome to Integral Calculus. Today we explore lesson 7.2, Integration of Trigonometric Functions, part 2. Number 1, Special Integrals. First problem is integration from 0 to pi 4 of square root 1 minus cosine 4x dx. We can write cosine 4x as cosine 2 times 2x and use the identity to solve this problem. Okay, so we have integral 0 to pi 4 square root 1 minus cosine 2 times 2x dx and use the identity. Cosine 2a is 2 cosine square a minus 1. This gives us 0 to pi 4 square root 1 minus 2 cosine square of 2x minus 1 dx. 1 minus 1 is plus 1. So we have 2 minus 2 cosine square 2x square root 2 minus 2 cosine square of 2x dx. Well, we can factor them number 2. And you see that we have integral 0 to pi 4 square root of 2. 1 minus cosine square sine square, so 2 sine square of 2x dx. We have root 2 on the outside, 0 to pi 4. Root of sine square is sine. And we don't need the absolute value because the sine of 2x is positive from 0 to pi 4. Sine 2x dx. From here, use the quick use up, use equal to x. So half of du is dx. And we have root 2 times 1 over 2. Antiderivative of sine is negative cosine, so minus cosine 2x. Evaluate from 0 to pi 4. Yeah. I'll do some substitution here. I'm gonna pull out the negative ones. We have a negative root 2 over 2. And we get cosine of 2 times pi 4. So that would be a cosine of pi 2 minus cosine of 2 times 0 is 0. Right. And this is going to give us the root 2 over 2. B integral 0 to pi sine 2x times cosine 3x dx. Well, to do this one, we're going to use the identity. Sine A cosine B is half of sine A minus B plus sine A plus B. And we have integral 0 to pi sine 2x minus 3x is negative x plus sine 2x plus 3x is 5x dx. I'm going to write a 1 over 2 on the outside. Yay. Sine negative x, negative sine x, 1 over 2, integral 0 to pi, negative sine x, plus sine 5x dx, 1 over 2. Antiderivative of sine x is negative cosine x, so we have a minus cosine x minus, and then here come the u sub. U equal phi x, 1 over phi du is dx. So this gives us the negative 1 over phi cosine phi x. Evaluate from 0 to pi. Minus is the plus, so I have 1 over 2. And cosine pi minus 1 over phi cosine phi pi minus cosine 0 minus 1 over phi cosine 0. Now carefully with this, then we're going to grab the answer here. 1 over 2. Cosine pi is negative 1. So minus 1. And cosine phi pi is the same thing, negative 1. So minus 1 over phi, negative 1. Okay. Minus cosine 0 is 1. And same thing, 1 over phi, cosine 0 is 1. Work out the fraction, and ta-da! We have negative 4 over 5. Two integrals of common trick that you will likely to see in the later section. First, let's take a look at the integral of sine x, sine square x, and sine to the power 3x. Integral sine x dx. It is negative cosine x plus c. Integral of sine square x dx. This integral 1 over 2, 1 minus cosine 2x dx. And we can split this out into a integral 1 over 2 dx minus 1 over 2 integral of cosine 2x dx. Split it easier for us to do the u sub. U is 2x. So 1 over 2 du is dx. Integral of 1 over 2x is half of x. And for this one, it would be negative half of antiderivative of cosine sine. Well, then we have a half, so multiply to half of sine 2x. And we only need a plus c, because plus c1, plus c2 is just another constant, c. Well, we can factor the 1 over 2, make it look a little nicer if you want. Or else you're just going to keep it like this, simplify the fraction. 1 over 2x minus 1/4 sine 2x plus c. Next, going to be integral sine to the power 3x dx. Split this out into integral sine square x times sine x dx. And we need to get rid of x, sine x dx. So rewrite sine square x as 1 minus cosine square x sine x dx. And then from here, it is clear that u has to be cosine x. Du is, no, be careful, negative sine x dx. So I mean sine x dx is negative du. So we have integral of 1 minus u square multiplied to negative du. So that is integral of u square minus 1 du. And we have u3 over 3 minus u plus c. So ta-da, do the substitution. Then we have a 1 over 3 cosine to the power 3x minus cosine x plus c. Pretty cool. Next, let's move on to integral of tangent, tangent square, and tangent to the power 3 of x. Integral tangent x dx. We did this before, but let's just redo it. Well, we know tangent. There's no antiderivative, so we got to write tangent into sine x over cosine x dx. And then we let u to be cosine x. Negative du is sine x dx. So this would be integral of 1 over u times minus du. Right? And that would be negative ln absolute value of u plus c. The same as ln absolute value of u to the negative 1 or 1 over u. Absolute value of 1 over u plus c. And do the substitution. We have ln absolute value 1 over cosine x plus c. 1 over cosine is the same as secant. So ln absolute value of secant x plus c. Integral tangent square x dx. For tangent square, we use the identity. Tangent square secant square minus 1. So integral secant square x minus 1 dx. And the antiderivative of secant square is tangent x. Antiderivative of 1 is x plus c. Oh, slick. Integral tangent to the power 3x dx. For this one, we're going to use the same trick as in the sine x to the power 3. Integral of tangent x multiplied to tangent square x dx, and use the identity on tangent square tangent x times secant square x minus 1 dx. Split it into two integral tangent x secant square x dx minus integral tangent x dx. For the integral of tangent x secant square x dx, we let u to be tangent x and du is secant square x dx. Oh, how nice. So this would be integral of u du minus, well, we know the integral of tangent x ln absolute value secant x plus c. Integral of u is the u square over 2. And we just have to do the substitution. And we have 1 over 2 tangent square x minus ln absolute value of secant x plus c. Very cool. One more integral of secant x, secant square x, and secant to the power 3 x. C. Integral of secant x dx. There's no antiderivative of secant x. So we just got to use a trick. And we can multiply this by secant x plus tangent x over secant x plus tangent x dx. You see why I multiply by this in a bit. Now we have integral of distribute secant x, so secant square x plus secant x tangent x over secant x plus tangent x dx. Now, do you see something here? Let u equal secant x plus tangent x dx, and du would be secant x tangent x plus secant square x dx. Ta-da! Integral 1 over u du, which is ln absolute value of u is secant x plus tangent x plus c. Everybody know the integral of secant square x dx, which is just tangent x plus c. Yeah, but what about integral of secant to the power 3x dx? Well, to do this one, we're gonna have to split the power. Secant x times secant square x dx. And here we don't want to convert it into tangents, because if we do that, it won't get us anywhere. The trick here is we use integration by part. We're gonna let this to be u, and this one is dv. So when du is secant x tangent x dx, and v is tangent x. uv secant x tangent x minus the integral of v du secant x tangent square x dx. Tangent square is you get a little tricky here. Because when you look at this thing here, you cannot use the u sub, right? And then if you integration by part, you're going to get a little messy. But if you use the identity to make tangent square into secant square minus 1, then we have integral of secant to the power 3, which would help us to do this problem. So the trick here is identity. Trick identity. Secant x tangent x minus integral secant x secant square x minus 1 dx. Now what we have is secant x tangent x minus integral secant to the power 3x dx. Minus is plus integral secant x dx. Oh, we can add integral of secant to the power 3x dx on both sides. This cancel out. We have 2 integral of secant to the power 3x dx equal to secant x tangent x plus integral of secant x is, and when absolute value of secant x plus tangent x plus c, and now divide both sides by half, and we have a integral of secant to the power 3x dx is half of secant x tangent x plus half of ln absolute value secant x tangent x plus c. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I will see you in the next video.